An aircraft sits in a state of despair in a field near Moscow and looks something like a spaceship that crash-landed on Earth. The Bartini Beriev VVA-14 is a remarkable aircraft that defied convention during the Cold War era. The United States and the Soviet Union were engaged in a fierce competition to counterbalance each other's military capabilities, relentlessly developing eccentric military technologies. In the 1960s, the U.S. Navy began deploying nuclear-powered submarines armed with 16 porous missiles. Russia had to come up with a counter to stand a chance. Robert Bartini designed VVA-14, one of the most ahead-of-its-time design for an aircraft. There is still no other aircraft to date that comes close to VVA-14. The story of this brilliant aircraft and its inventory is shrouded in mystery. This aircraft could take off vertically, hover in midair, land on any surface, cruise at high altitudes, and harness the ground effect. With a wingspan of 30 meters and max speed of 472 miles per hour, it only took 3% crew to fly. Bartini was known for his out-of-the-box ideas, and he was convinced that this should be an efficient means of transport. Hydrogliders were yet to be built aircraft types that could provide efficient transport. The pressure buildup on the underside of the wings created a cushion of air that would skim over water, harnessing a phenomenon known as the ground effect. Air deflects downward and around the wing and is compressed, creating a pocket of higher air pressure, resulting in less drag, more lift, and much higher efficiency. So unlike conventional aircraft, which have to be as light as possible, ground effect aircraft can use mass and size to their advantage. In a collaborative effort between Bartini and Beriev Design Bureau, the development of prototypes was structured in 3 phases. The VVA-14 M1 served as an aerodynamics and technology testbed, initially featuring sturdy pontoons at the ends of each central wing section, but later replaced by inflatable pontoons. In 1974, the inflatable pontoons were successfully installed, despite encountering challenges. Following the water taxi test, sequential flotation trials were completed, initiating the flight testing phase. Advancing to the VVA-14 M2, the design incorporated 2 starting engines for lift, utilizing a cavity under the wing, and later incorporated a series of lift engines to enable VTOL capabilities. But they failed to create such engines for 51,119-pound aircraft. The most crucial component of the entire concept was the vertical lift jets. This model also featured fly-by-wire flight controls. The final phase, VVA-14 M3, envisioned a fully equipped VTOL vehicle armored with weaponry, equipped with a computerized anti-submarine warfare system, magnetic anomaly detector, and other operational equipment. Powered by a combination of 2 cruising and 12-lift turbofan engines with an estimated range of 1,522 miles and a cruise at 32,800 feet. The first Bartini Beriev VVA-14 prototype was completed in 1972, and its first flight was from a conventional runway. In 1974, the inflatable pontoons were installed, though their operation caused many problems such as inflation and deflation, and there were difficulties in making engines for the lift jets. In 1974, the aircraft underwent successful flotation and water taxi test, which the amphibious aircraft entered the flight testing phase. Despite its innovative design and impressive capabilities, the Bartini Beriev VVA-14 never saw active service. The project faced a major setback with Bartini's demise in 1974, ultimately leading to the termination of the program. Of the initially planned 3 prototypes, only 2 were constructed. Presently, the VVA-14 M1 sits abandoned at an Air Force museum outside of Moscow, while the second prototype was dismantled. While the VVA-14 never fulfilled its intended role, it remains a fascinating chapter in aviation history, providing a glimpse into Bartini's unique mind. The lessons learned from its development contributed to the advancements in ekranoplane technology and influenced subsequent designs.